also accepting the participant. Okay. Okay, good evening to everyone, dear students, dear professors, dear faculty members. Welcome to our first event of ArchiDesign Timber Talks series for the 2024 fall semester. We have a valuable guest from Denmark, partners of CF Moller Architects, architects Julian Weyer and Ola Jonsson. It's my pleasure to be here and to introduce CF Moller Architect, as one of the Scandinavian leading architectural company with 100 years of award-winning work in the Nordic region and worldwide. Their vision is to improve life for people and planet. When I read their vision, I thought the material can be used or using timber as a construction material. And more than 15 years, I am trying to follow this office works by my friends for our working in Europe, in Norway, and by your web page also. So it's so I am very happy to this evening to sharing the knowledge. You will share your knowledge with our students and our architects and academicians. And I want to give some information about our speakers. One of them is Julian Weyer, and he is partner of CF Moller Architectural Office. He studied at the Aarhus School of Architecture and has been with CF Moller Architects in 1995, becoming a partner in 2007. He works across Europe with innovative architecture, landscape architecture, and urban design, including large master plans, infrastructure projects, as well as landscape and urban space projects in combination with a variety of different building typologies, where public space and buildings go hand in hand with social and environmental sustainability. Our guest is Ola Jonsson. Ola is also partner of CF Moller Architect and has been with this office since 2008, with a Master of Architecture from the Aarhus School of Architecture and the Royal Institute of Technology in Stockholm. Ola is at the forefront of sustainable design with focus hybrid and timber buildings and social sustainability with added value for people and cities. Our topic is today, as you've seen on the screen, new Scandinavian timber architecture. What is new for us? What is new for Scandinavian in timber innovation? We will see with the presentation of Julian Weyer. The desk is yours, Julian.
Thank you very much, and thanks for the invite. So, exactly as you said, we come from a very long tradition, 100 years. Our office turned this year. So we're very much part of the whole Scandinavian modern movement. I mean, part of shaping that, and also this cross-disciplinary working which lies behind that. And I think one of the important points is that up until 60 years ago, maybe 70 years ago, we mostly built healthy buildings, which we are today transforming a lot of those buildings. They're not being demolished, but they're being transformed. They can live on. And when they're being transformed and reused, you find that they are quite easy to work with. And one of the things that happened post-war was that new building materials started emerging and experimentations took place, which led to buildings that are today perhaps a little bit more problematic. And that goes hand in hand with the whole discussion of embodied carbon, which we'll come into a minute. And that's been part of driving this whole process of timber architecture emerging. And for our 100 years anniversary, we made a number of things. We made a movie, which you can see on the line, but we also made these centennial numbers, which pretty much tell the story from bricks in the 1920s and 30s and 40s to concrete in the post-war period, and today moving on into the timber revolution. And a big part of that has been the fact that we work across Scandinavia. So originally a Danish office, we are now a pan-Scandinavian office. And that makes a big difference in also where the influences of the architecture comes from. And Ola will get into that as well. So just looking back shortly, sort of what happened in the Nordic countries in the 1970s, there was the oil crisis, which really for the first time brought the issue of efficiency and energy efficiency to the forefront in architecture. And then it was all about heating at that time. So saving energy in terms of heating was the big thing. And we came from an absurdly high level looking at it from it today in terms of how much energy buildings were using, but that was never something that was put into question before. And then in the 2000s, there was a big focus on the operational energy and especially the electrical energy in buildings and optimizing that. And a lot of work was done in pushing that, squeezing the operational energy balance of buildings, and also really the heat savings that were able to achieve with the kind of approach that you find in passive house architecture, for instance. So all of that was embodied in building regulations in the Scandinavian countries throughout the 2000s. And that means that in a future scenario, so the 2020 scenario, we no longer have that much focus on the operational energy like the heating and the electricals, because that has been optimized to a degree where the last little percent of saving maybe doesn't make much sense. Rather, what makes a difference now is this block which has just been sliding down the scale, which is the embodied carbon in the buildings. It used to be a smaller part compared to the energy that was used in buildings, but now it actually is the bigger part. So this is where our focus has shifted to. And if we look at that sort of in the typical multi-story buildings, you'd see that the embodied carbon is way bigger than the actual energy use. And if we perform tweaks on the energy use, which we of course still do, we still try to optimize in every which way we can, it doesn't really bring the kind of savings that looking at the focus of or focusing on the embodied carbon does. So as a background, this is the logic which has been driving, for instance, the use of biogenic materials in architecture and especially in the Nordics. And this had to do with the fact also that we come from a tradition of building where prefabrication has played a big role for many, many years. And it's mentally, at least, an easy shift to go from prefabricated concrete panels to timber panels, for instance. Of course, technically, it's not always the same, but it's close at hand to make this transition because we're used to thinking in these modular ways. And that leads to the Swedish perspective, because when this whole thing started, it was very much Sweden and Norway and Finland, the Nordic countries that have a big amount of forestry, which were drivers to in the first push for change in this. And this resulted, for instance, in research collaborations, which Ola can talk more about, where we went into partnership with other companies and institutions and universities as well in trying to develop these concepts to be able to bring them to the market.
Yeah, shortly, Sweden has a long tradition of building in timber, and I'll get back to that as well. But research project actually started out with a need for a change in how to use our timber in Sweden, and the union for timber, we're looking for new challenges and new jobs, and then that set off a discussion, and that ended up in a research project with Vinnova, which is a finance center for research, and the Linnéa University revised its academic level of it. So that's the research project that we finished a few years ago. At the moment, we're involved in another much larger research project together with other colleagues around Europe, and it has quite a technical aspect on it, and it's financed by the European Union's Horizont. It's a 10 million euro research project, so it will be presented quite soon, I think, the end of that. But the purpose was to find common ways of using the Eurocodes to build in all over Europe. But basically, the most important thing about building in timber, in my perspective, has been that it has a life cycle. It's a circular means of building, especially in Sweden, where we have a large degree of woods. Where you take the timber and you build housing or offices or whatever you want to build, and try to build them with great quality so that they will sustain over a long time, and with the embodied carbon. And then after hundreds of years, hopefully, we can transform it into a new building type. We can take it apart and make new buildings, or we can make building materials, simple building materials, or other organic materials like textiles or anything else. And then in the end, it will be either burned or go back to biomass. And that just says that the carbon that the woods takes from the atmosphere is borrowed and then handed back to atmosphere again. So it's the same carbon that sort of circulates around instead of creating new. So that was, for me, the main reason to work like this. Sweden or Scandinavia, depending on how you see it, consists of about 70% of forest, and a large deal of that is sustainable forestry, which means if you take down a tree, you will replace it with 2 or 3 new ones. But there's a lot of research and science connected to that, and really doing it in a sustainable way, and it's developing. You can take the next one. Also, if you compare the production side of timber and concrete, I think the visual sort of tells you the true story. This is one of the cement factories in south of Sweden, and it creates a great deal part of the carbon dioxide in Sweden. 1/5 or 1/4 of the whole carbon dioxide production of Sweden is from this factory. So it has a big effect on our environment. And engineered wood or timber is many different things. CLT is the most common talked about today, but there are so many different versions of it that we work in different timber hybrids, and it just has some of the best qualities. Is of course the lightweight and the environmental part, but it's really easy and industrial material to work with. You can get a really high precision and linear process of the building. We can continue. We have so many pictures, so I have to go really fast. But it also creates some new possibilities. For instance, and this is a building in Switzerland where they flew all the building parts up with a helicopter on top of the mountain. But we also have in Stockholm, we have the subway. We had a lot of spots where we're not able to build before, and now we can build multi-story buildings in the middle of the city and make it more dense. We can also build on top, on fills, and we can also build behind other buildings and so on. So it creates new opportunities, which is actually can be sustainable in the way that we don't take new land to make new buildings, but we can reuse existing land. Sometimes we have critics that says that timber is not long lasting, but we have proof in Scandinavia and Turkey and other countries. If you just do it in the right way, you can actually have buildings that stay for a very long time. This is a stavkirke, a stav church in Norway. It's been around since the 1100s, so it's still standing. One of the things that came up, not from the beginning. When I started 15 years ago, it was not so much discussion about health, but evidence-based research now show that it has a great deal of effect on humans, both including it in the structure, affects the climate and the acoustics and so on, but also visually. There are several reports that show that, for example, in hospitals or elderly homes, you can see people becoming healthier quickly compared to other types of buildings. And I think that's one of the main things that we try to work with all our design. I think we have matured a bit as well. We started out talking a lot about buildings, this building and this building, but the main concept is to change our cities from producing carbon dioxides to actually absorbing carbon dioxides, and so when we brag about making tall buildings, that's in reality not so interesting. It's about the critical mass of our cities and how we plan them. Yeah. And this is my little slogan, but in general, I work more and more with hybrid buildings, and the best material is not timber. The best material is the one that we're not using. So we have really advanced simulation and digital tools today that we can actually show evidence of what's the smartest way of making our buildings. And it's not always timber. Sometimes it's timber concrete or timber steel. But we always, the base is, the beginning of the talk is always how much timber can we use percentage-wise. And I throw in a little quiz. I used this in a presentation recently, so in Sweden. So this is a bit different. But do you know what the largest timber building in Sweden is? So this is a question for you guys. Have you ever been to Stockholm? No. We can.
Yes, but yeah.
Do you know
don't know the answer? Yeah.
It's actually the Royal Castle that was built a couple 100 years ago, 300 years ago. It's 58,000 square meters, and more than 50% is made from timber. The old one was made entirely of timber and burned down, so they learned what parts not to do in timber and so on. But in as I said before, in our history, a lot of houses are built in small houses are built entirely in timber, but old slabs and so on in buildings from the last few hundred years is timber, and therefore the formal description in Sweden for a timber building is when you use more than 50% of the construction is timber. So that's why this one is still a winner, so to speak. Yep.
Right. And to give you an insight on sort of how this timber knowledge ties in with how we work with sustainability in general, it's part of the original design idea, exploring the variations, where the use of material also becomes a factor, and then tying that to various systems of documentation, which could be DGNB or BREEAM or LEED or others. Point being that it has to be a pretty holistic site. And there's been some recent developments, which I'll come into in a minute, which are quite interesting in pushing these agendas. We have over the years developed particular scripts and tools which are used for initial assessment in the sketching phase of daylight, of microclimate, of overheating, all of these different parameters that can be studied in models from an early age on. But what happens now is that LCA comes to the forefront. So life cycle analysis is now part of a mandatory building regulation requirements. And this is an interesting change, and I think the Nordic countries are the first to have made this move. I would expect this to happen in more countries over the years, but of course the question is how fast will it be? So in Sweden, Norway, and Denmark, we now have climate regulations as part of our building code, and that means that there are caps on the embodied carbon. You can only use so much. And in Denmark, we did it in the same way as it was done 20 years ago when it was about energy savings in operational energy. We started out with a building regulation, with a building code, which was tightened every 2 years and sort of stepped down. So the top curve would show you what would be the mandatory requirements coming for the next year. So for 25, 27, and 29, you'd have tightening of building codes. Earlier on, it was operational energy. Now it is embodied carbon. So these numbers here, 12 down to 7.5, are the equivalent kilograms of CO2 equivalent per square meter per year. Underneath that, the lighter line is the voluntary emission class, which was always an offer to say, let's do an experimental emission class where more ambitious builders and more ambitious architects and designers can try and meet tightened regulations. Now, what we know back from the 2000s, when it was operational energy, is that the plan is always to, at some point, skip the top line and go to the bottom line. As soon as it's been proven by the first projects that you can achieve these kinds of savings, the mandatory top line actually moves down and the voluntary class becomes the mandatory class. And this happened already before the first 2 years were gone. We now actually only have the lower line as building regulations for the future. So that means that we are looking at a quite ambitious transition. We can't really build as usual anymore. So classical business as usual is out of the question. We now have to think about materiality as a key forefront. And this goes together with the whole EU taxonomy, which also plays a role in this. I'm not going into this in detail, but it's certainly something that affects the way that we build. So first off, we've used the LCA data we have to create a carbon construction catalog, really, which is a base that we can use when we design buildings. We have different build-ups and wall typologies, etc., and to know what the LCA data are for each one, because we have to make these informed decisions very, very early. And we've also developed scripts, because the problem, this kind of graphics, you usually see that together with BIM or with other sort of complex project movements where you say, well, in the beginning, there's a large possibility for change because you're at an idea stage. And as soon as the idea becomes more and more concrete, the window for change becomes smaller. And in the end, change is detrimental in a project which is already in the advanced stages. So that becomes tremendously costly. Now, the problem is, as I just showed you, we project carbon values into the future. So if you want to make a building application in 2 or 3 years' time, it's not necessarily the same values as today. So we have to have tools that can tell us continuously throughout the design process, where are we in terms of embodied carbon, and are we meeting the targets? Are we meeting the future targets that we have to amend to? So we need to look at these values and these data before we actually have a full building model that it can give us that kind of info. So those projects I've worked on BIM, and of course, if we have a fully fitted out BIM model with all the data and the materiality, and then you can make LCA calculations. But what about the early stages? So I show you here is an example of what it looks like, the tool that we've developed that ties in together with the LCA calculation tools that are used to assess these values, and what that looks like on an early stage model. And this is a model that has absolutely no data on materials. So the only thing we can do is we can work with probabilities. So we can say, typical type of construction, what kind of LCA would that be? In this case here, you'd say standard solutions. That's what the contractor would use if we didn't make any particular specifications. And then we can generate an early LCA file, and we can see, well, where do we end up down the line? If we have the building application in 3 years, are we still making the cut? Are we still meeting the requirements? And this data can be imported automatically, and the LCA calculation tool is an open source tool which is used all across the country and is available for everyone to use, based on a shared knowledge database. And when you see that you can't actually make the requirements, then we can change and implement more biogenic constructions. And this is really the key point. We have this early on informed conversation with clients about if particular building typology or size or dimensions, if we want to implement that into the future requirements, we need to look at the materiality just as an equal thing together with all the other parameters that we are looking at. And here, in this case, we can say, well, that kind of volumetry, that kind of building will actually achieve the LCA values and can keep below that if we use a certain amount of biogenic materials. So this is a way of approaching the fact that we don't really know yet in an early stage what we're going to do, but we still have to make assessments where we will end up. And when you talk about these values that now we are looking at in the future here, we are looking at, in 1 year, we are looking at 7 kilos CO2 equivalent per square meter per year, and that will drop down, further down to 5. What does that actually look like? And this is just an example here, a residential project, which is a completely modular timber construction, no elevators, no concrete, no cores in this building. It's made from entirely prefabricated modules, so it's put on site on a simple concrete slab, and otherwise everything else is either biogenic or recycling material or leftover materials. And this is an aesthetic that I don't think every single building in Scandinavia will look like in the future, but this is certainly something you'd have to understand. This can go by about 6 kilo CO2 equivalents per square meter per year. So it's well within the range of permissible values, but also it shows you that if you were to make a basement here, or if we had a big lift core or something, already then we'd see issues with reaching the targets. And then there's the question, what comes beyond this? So we did a competition/research project, which looked at the possibility of going way below those targets and going down to less than 2.5 kilos CO2 equivalent per square meter per year, something which is extremely ambitious in a building perspective. And the idea here was to say what kind of architecture, what kind of living way could be an approach to reaching this. So again, it's probably not the solution for the future, and not everything's going to look like this, but it's an example of how much does it actually take to reach those targets. And in this case, the target would be going from this roughly 4 times planetary boundaries consumption that we have today down to being within planetary boundaries, and then actually looking at what it takes to go below that and down to truly net zero. Definition of net zero is a very tricky issue, but if we want to say that you're 100% climate neutral, we need to go below the planetary boundaries. So starting up at the top, business as usual is where we are today, and that's not even all bad in the Scandinavian countries. And then using timber construction, using bio-based materials and circular building and all the energy savings we're doing, we can push the envelope down from about 10 average kilograms of CO2 down to 2.3. So there we are technically within the boundaries, which is about 2.5 level. Then if we want to go further down, we have to start looking at the areas and the volumes we're building, and we have to look at reusing our materials another way than, for instance, just burning timber. And that can then give us the opportunity of coming all the way down. So as an example here, this building system employed 78% bio-based materials, and the rest would be recycled materials, for instance, metal sheeting and that kind of thing, in order to get down to these super ambitious energy values. But we were also looking at the fact that this was a housing concept. We're also looking at the fact that we need to actually make the units smaller. So Denmark, I think, has a record for most square meters per person in residential in the world, and that's just not sustainable in the long term. So we have to also look at that, use more shared areas and communal facilities, and then optimize area like that. So this is, again, is an illustrational example of what would it take to get all the way down there. But bringing that up into the big scale and showing how we can work with the larger buildings, that's where the timber construction comes into practical play. One project that we are working with right now, which is completing soon, is Denmark's really first large-scale timber building, a government office hub, which is built in the town of Odense, where the idea was already to work with a modular architecture which could adapt to timber construction, but also could adapt to the urban situation. So we had like a whole series of diagrams here which show that we optimize the volume or create a large volume. In this case, it's a fairly efficient building, actually. It makes the most of the site and the space there. But the idea is to also work with it in such a way that it creates a good urban environment, a good microclimate, enhances the greenery on the site, and in the end still works for rationalized timber construction. So that means that we are looking at bringing together here, dividing the volumes, breaking down the scales, bringing in the edges of the city, adapting to the context in terms of heights, and then use the daylight to shade the building and use the roof terraces, activate the roofs, and then using architectural design of facades, different variations to blend in with the surroundings. So all of that kind of becomes the language of the building here. And it's a project, as I say, it's about to complete, and it is a very simple structure in a way. It also has a high degree of timber compared to the modularity of other structures. It's a very, very simple construction, and it was part of the thinking here that because we also have to think beyond the use that the building has right now, we need to project where we're going to be in 50 years' time and how can the building be reused. So we have a simple passive design where solar shading is already integrated in the facade, so we can do without external sunscreens. And then we have very, very simple column and slab construction, which gives us a high degree of freedom when it comes to the use of the building in future perspectives, because there are no beams here or downstands or upstands, so that limit the use. So this kind of goes across this whole, it's a very simple sort of shelf-like system, which means that we actually have a large range of adaptations. It can be transformed in future scenarios, and it has a high flexibility in terms of also what kind of installations, whether it needs ventilation, for instance, or not. All of this is adaptable. And on site, it's really a simple construction as well. As you can see, it's timber columns, timber slabs, and then only point-wise concrete cores, which is the hybrid component here. And that's then covered in a recycled aluminum facade with this solar shading efficiency. And a lot of actually quite beautiful details can come out of that when the whole timber atmosphere on the inside, as Ola was talking about, is certainly also something to do with the healthiness of the work environment. And one step further is a project we're doing in Berlin, which is the Ministry for the Environment, the German Ministry for the Environment. It's just sitting right next to the Parliament of Berlin, and a tricky site and a tricky building because it's supposed to be a showcase for circular and low-tech construction in Germany. A sustainable approach. And what we found is that we are in an urban environment where if we want low tech, which means in this case, no ventilation system in the offices, just natural ventilation by opening the windows, first off, we have to look at what kind of urban environment is on the outside. And we find that it's not very green. So the idea was first to create a green island. So if you actually open your window, it's into a pleasant microclimate and not a busy big city. And the next thing being that if we want to make a low-tech building, we can't do an introvert building. So we can't have something which is closed in on itself. We need something that is extrovert and outward looking. And this ended up in this kind of strange structure, which looks almost like a tree, which is unintentional in terms of design, but it works brilliantly because this is open to all sides for daylight and for natural airflow. And then combine that with a building where the facades change depending on the amount of sunlight they get. So higher up, actually, the facade openings are smaller, lower down, they grow larger. So it's a very sort of organic expression of the situation the building is in. And this is then combined with, there's thousands singular offices in there, plus some communal office space, but then also particular spaces like lobbies, foyers, exhibition rooms, etc., which make up a special atmosphere and where we use the timber construction also to, in this case, create a dramatic ceiling in a lecture hall or have a vertical atrium that bisects the building. All of this is something where the timber comes into play. But really, the key point is that sort of the standard office module, of which there are more than 1,000 offices in this building, that actually has to be the optimized core unit. And here is an example, as I said, a single office, a single window, and the facade, which is designed in such a way that the actual daylight loads on the facade are reduced, and the openings get smaller as there's more exposure. So depending on orientation and height in the building, the modules change. All of this has been calculated office per office per office. And then we have to project the climate data. So Berlin, which today already has pretty hot summers, in the future will have a climate which is more akin to Rome or Istanbul probably. And therefore, we also have to look at the projections in the future scenario. And again, there's no cooling, there's no air condition, there's no ventilation here. So what we rely on is that we have a simple ceiling fan, and then we use clay in the building. So clay as a material for partition walls, for instance, means that we have a 2-degree lower room temperature because of the retarding quality of the clay in terms of adaptation or change in room temperature. We use the night cooling, so simply opening the window and leaving it open at night will cool down the building, and the clay will postpone the reheating. So it's sort of small tweaks which make that difference. And we looked at a lot of different, you're not supposed to be able to read all this slide, but we, just to say, we looked at a lot of different variations of hybridization from an all concrete to an almost all timber building, and then try to find the optimal way in between. As Ola said, it's not only all timber buildings that make sense. It's the use of the material in the right place. Here, for instance, we wanted a lot of green on the roof, and heavy loads from that mean that we have a concrete core and then we have timber slabs on the outside. And again, with the timber slabs, we also looked at all sorts of different variations and looked at their different build-ups and always compared that to a standard concrete construction, as any contractor would do it. And then we looked at the individual quality of the timber slabs and found that actually one model which worked quite well is one that is very akin to, as I said earlier, we're looking back to buildings which are now 80 to 90 years old and are super healthy buildings. For instance, a ripped timber slab like you have on the right side here with a clay fill inside the ribs has really good thermal performance, has really good sound performance, which is as said, battery sound transmission is often a big deal in timber buildings, but it also has a really good microclimate or indoor climate efficiency. So this is the kind of construction that we'd be going with. And if we open 90 or 100-year-old buildings here in Scandinavia, quite often this is the kind of construction we'll find in there. And another project that we're doing right now in Germany, also completing, is in Munich, a large-scale office building there, which is a market rental building. And therefore, this is divided into smaller units. It's derived in very much the same logic as the project I showed you in Odense, so that we have a number of buildings tied together by an atrium on the inside and a simple, efficient floor plan. And then these adaptations to context, which mean that it makes sense in its overall setting. And here we're looking at using the timber in a very visible way on the inside to have a really true timber atmosphere, because it has a fantastic value, as you heard. It creates something special in terms of the feel and look of the building. And here on the left is a render of the offices, and on the right is that's actually a shot from the mock-ups that were done on the building side. Here we are using beech wood. So this is not a CLT, but basically plywood of beech, which has a high tensile strength. And therefore, we can do a beam construction here, which has a much larger spans and different properties. And we looked again at optimizing the different slabs in terms of having these larger spans, creating more freedom in the floor plate. And this is what it looks like in construction. You can already see that there's this ribbed structure underneath the slab here and relatively few columns, long spans. And in detail, how this feels, and again, it will be visible. So it becomes part of the interior design. And as this is a very recent image from the construction side, it'll be completing early next year, where you can see the timber on the inside. There'll be this large sitting stairs coming down. And so it's going to be quite special atmosphere, this building. And the last project in Germany that we're working on right now as well, also under construction, is a school. And it's interesting because timber in schools can also play an important role. We were looking to design a different kind of schools, actually a Scandinavian inspired school in a German design setting. Most German schools, I'd say, a little bit old fashioned, whereas there is a real interest in trying to push for new ways of looking at schools. And this is an example of trying to think differently about how the school design can be, using an atrium on the inside, for instance, to activate all areas at once and create something which, seen from the top here, is pretty much sort of a build-up of different terraces, which can be used both for play but also for educational purposes. So every level of the school has access to the outdoor, and the whole thing is surrounded by a large park, which is also a public setting. So school is actually part of enhancing the quality of the surrounding city and the urban areas. And it's been the idea to put a lot of functions on the ground floor, which are not just for the school itself, but can be used by others. And together with this outdoor landscape where it can interact inside out, that creates a new kind of situation. A lot of Scandinavian schools already employ this thinking, but in Germany, it's not that common to have those shared facilities like this. So just as it's setting an example for sustainable construction, it's also pushing the envelope for how schools can work. And on the inside, you have sort of a street running through with library and music center and youth center and a lot of other functions which are already pre-thought to be used, not just by the school, but by the city. And then it sort of draws you all the way through. And we have this atrium opening up in the middle, creating a forum area where everyone can come together. There's possibility to have events there. We have canteen and cafe alongside the school. And we're actually looking also to open some, for instance, here the science clusters would no longer be closed rooms, but this would actually be open rooms which join this open space and create visibility for what's going on in the school. And you can see all of this is combined with a highly visible timber construction. So this is one of the key things of the school will be that you'll have visible use of timber with that indoor atmosphere and the acoustics and the warm feel that it gives. And in the individual areas, it's not really classrooms, it's more like teaching areas. You'll see that also here timber plays a big role. So this was one of the key points of saying we also here we work with a concept with a low level of technicality, sustainable materials and circular concepts. We're actually looking, or we're making material passports of everything that's used in this building, so in this way that already in the future you can tell exactly what the building contains, what it's made of, and what the purpose or reusability of every single material is. And there's combines into this sort of unusual school architecture, which translates directly into the timber construction. Again, here you can see there are a few concrete cores, and then the outdoor stairs, which are part of the fire escapes, are in concrete, but everything else is really timber. And the timber construction, again, here was worked out with the thinking that what happens in future adaptations, we might not put a lot of technical installations in right now, but there should be possibilities to fit that in the future scenarios and use this timber construction in a quite simple modular way, even though the school has some odd shapes. And as you saw in the movie there, this route running through here ties the different uses together. And inside each teaching room, we also use the timber in such a way that here you have the opportunity, for instance, to hang stuff from the beams. So you can literally reshape the classroom in a three-dimensional way, both in terms of lighting, but it could also be different aggregates, or it can even be furniture that's suspended from the ceilings. I'm trying to activate the whole space. So everything we moved on here was always with the thought of how does that create a value in the day-to-day life of the school and in the life of the pupils. And because it has the sustainability goals, we are also looking to do a timber facade. So the entire school will be clad here in prefabricated facade modules with a timber cladding as well. So it's really sort of a highly sustainable material palette, and everything, as I said, is pre-screened for environmental healthiness, and then it's also registered in material passports, which mean that we have a full register of everything that's in there. So those were a few of the German projects that we're working on in the moment. And then Ola, you have also a portfolio of just what's going on in Sweden right now.
Yeah, keep it quite short. It's there's a few Swedish projects going on at the moment, and this is actually it's going to be announced in a few days. So this is the pre-hand information. It was a competition that we won this summer, and for a new university building in central Malmö. It's a 20,000 square meter building, and it's going to be a hybrid. So in this type, this is what I think is really fascinating about working with this now. There's so many versions of hybrids, and this version is timber pillars with beams, and then it's hollow slabs for the concrete slabs simply, which makes it possible to have a really flexible floor plan with less pillars simply. And but just the same as Julian told, we want to integrate the structure as part of the design and the feeling of the building. And this building is also joined with the transformation of an old historic magazine building down at the harbor in the city. So there was this interaction between transformation and renovation of an old building included in the design, and then with the clean cut, you go into the new building with a new industrial way of building, sort of a industrial way. And this is another project also in Malmö. It's called Hyllie Play. It's an office building. It had a triangular local plan that we had to adapt to, and we were a bit worried about that. But actually, we found a system within the system for this as well. It has the same kind of hybrid with concrete slabs and timber pillar and beams. And it has a quite strong character in its silhouette as well. And yeah, so it's just another hybrid building, but it has a lot of ideas for. It's called Play for a reason. It's all based about activity and health. So there's a sports hall inside and so on for the people working in the building. Yeah, you can go to the next one. This is a Congress building, so it's an office, hotel, and a big conference hall. The conference hall is thought to be built out of timber entirely, while the other parts are more hybrids. And it's downtown Lund. You can take the next one. Yeah, this is inside the aula. And it's not Julian standing there, but you could think so. It looks like it. Yeah, just took a few projects of different character. This is a new train station and bus station in the very north of Sweden, entirely made of timber. It's a project we're working on right now, and it's quite large timber structure, but in one floor, so it's spreading out. So it doesn't have to take a lot of weight. So therefore, we can do it entirely in timber as well. So there's a cross section, just showing how it works with the landscaping as well. Yeah. Another central station is a traditional thing in most countries in Europe that you make. Train station has this sort of either cast iron beams or in timber beams. And this is a glue lamp beams that we took to sort of an inspiration from the old historical train station and did into a modern design. And take the next one. I don't know if there's a section. Yeah, this is an interior image that's showing how timber can be part of that design. This has very high security measures because of the train, so the slab is made in thick concrete, unfortunately. It has to take explosions and so on, but it has the character of a timber building. Yep. This is one of the first pure timber buildings that we did. It was a housing project, and at the time, the tallest timber building in Sweden. It's not 10 years, but almost. And it was never built this high ever, and so it was sort of an experiment, and we decided that everything should be in timber, so floor slabs and walls, balconies, elevator shafts, yeah, everything is entirely made out of timber. And it was quite interesting to see when it was erupted. There was 3 guys, about 20 years old, who built the whole building with a crane, and it went really, really quick and fast. And this is a residential building which is fully working now, and everybody seems to be happy about it. And of course, it has a really good or low carbon impact. And this is another image in the winter. It's standing in Västerås, a small city in Sweden. Yeah. So just some detailing from the elevator shaft and some electrical preparations. And also when you work with these sort of telescopic connections between parts that will move or compress differently. And then just zoom in on floor slab and a wall connection right there. You can take the next one. Another housing project in outside of Stockholm, made from CLT entirely, and it's a renting project, housing, and yeah, it was finished a year and a half ago or something like that, and it seems to work as well right now. Can take the next one.
I think that's it. Yeah.
That's it. Okay.
Yeah.
Good. So there's time for questions.
Okay,
Yes.
thank you very much, Ola. Thank you very much, Julian, for the detailed and so informative projects presentation, because we already seen many different functions like school buildings, housing project, and train station. Central station projects. We already seen a project from Munich, Berlin, and Malmö, European cities. And then thank you very much for the projects and for your presentation once again. Thank you.
You're welcome.
Maybe our students or academicians can ask some questions to you. Yes, Aisha, I think you have a question. You can open your camera and ask your question directly, okay?
Yes, hello. First of all, thank you very much. It was like very nice to understand up-to-date architectural information, let's say. Because like I'm from Ukraine, and in Ukrainian universities we don't study architecture so much like about the contemporary techniques and contemporary materials and so on. So like it's really valuable for me to hear all of this and to experience this. But the question is, like when you were talking about the school in Germany, you said that like we're doing the design project right now, which is Eco Campus for high school. And for us, in our brief, we have to somehow think how to implement the public functions into the very private environment of high school. And for specifically for Turkey, it's very challenging considering the existing educational system. And so opening the whole school for public, also considering the age of the children and so on, like it's very difficult. We don't have any examples in Turkey. I personally also am from Ukraine, and in Ukraine we also don't have that, like maybe on different times, but with a lot of security checks and so on. So I was wondering about if I can ask about the program, about the architectural decisions, about the inclusion of public spaces on the, like as you said, on the ground floor of the school. How can it be, like I really like the sentence, pushing the envelope on how the school works. How did you include the public in there?
Well, the idea really comes from the development that's been happening in Scandinavian countries. So we're taking a lot of inspiration from Danish and Norwegian and Swedish projects into it. And those have had the view that although there are potential conflicts between users, there are numerous reasons for doing it anyway. And the first, of course, is the fact that any building is a cost and a resource, so it has to have more than one function. It needs to be able to somehow give back to the surroundings. So every institution, school or university or whatever, also has to face the fact that society isn't necessarily going to fund it unless it can actually make you could almost say a good case for itself. It needs to have a reason to exist. So it's no longer just these closed ivory towers. They very much have to also be part of developing urban environments or whatever setting it's in. And that also means that if you start opening, you also have the opportunity to change your teaching curriculum, because then suddenly this interaction with the outside society is also something that schools and universities can use in their daily curriculum. And then lastly, as I showed you, these carbon caps that are coming now can, for instance, for some type of buildings, that can be quite difficult to reach. If one of the key points we have, or one of the key sort of possibilities for change is actually to, for instance, squeeze and minimize the floor areas, that doesn't really work in educational architecture. It's not a good idea to build a too small school. So what you can do is you can build a more multifunctional school, and that way you can still have a positive carbon outlook, despite the fact that we have maybe more area. So those are the theoretical drivers behind it. And on a practical level, I mean, we have had ranges of projects here in Denmark which go all the way to the fact that we have now built schools that are no longer really schools. They're open public buildings wherein a school can also reside. That's typically for older pupils, not necessarily high school, but at least the older classes. Smallest kids will not usually be exposed in the same way. But we have these examples where the school completely dissolves into the public use of a building or a facility. In most cases, it's more about trying to say, get rid of the fence around the grounds, make sure there's activity all the time, and then use some of those functions that a school can already have, like a library, a music or a science center, art center, those kind of things, which have an easy potential for public use, both outside school hours, but in some cases also during school hours. There's also a possibility that you can have events going on there which benefit both school and community. And then position them in such a way. Here in this example I showed, for instance, it's all on the ground floor connected to the landscape, and then the more schoolish environments are on top of that. So there's a natural divide between the two. And that way we can try to mitigate some of those potential conflicts between these uses.
Mm-hmm.
Okay, Aisha, I think this is enough for you.
Yes, I'm still writing. Thank you very much. Thank you.
Okay, thank you for your question, and thanks a lot for the long answer, Julian. Thank you very much. Detailed answer. And Sinem Hocam has a question, I think.
Actually, Demet Hocam, there is a row, Fatima, then Ingi, and then
okay.
me.
Okay.
Yeah,
Fatima.
you can go.
Okay, Fatima.
Professor?
You can ask. Yes, you can ask your question, Fatima, please.
Aisha?
Maybe first you can introduce yourself to our guest, okay? Which class you are attending, maybe you can say.
Now I'm the 4th year student in the 7th semester of the architecture, and I was one of the students of the Demet Hoca in the timber class. And thank you for your explanation. That was so useful for us. And now I'm so curious about the transferring the timber to those countries that they don't have this opportunity to use the to use trees and timbers. I mean, they don't have that much jungles like the European countries or the Canada or what else. Yeah. Now I'm curious about the transferring. So how can we transfer these too much timbers to those countries?
That's a really good question, because that's also one of the things that is emerging in our discussions. We can't just replace everything with timber. We can only do that if we reduce the overall volume of what is built. Otherwise, there's simply not enough timber. And as you say, the timber is not equally distributed. So even Denmark has a relatively small amount of forestry compared to Sweden and Norway, for example. So if we make a timber building in Denmark, we typically import the timber from the neighboring countries. That's not a huge risk, but it could be in other scenarios where it actually becomes difficult. It can be an economical difficulty buying timber. And so that is a very sort of, I don't have a clear answer of how it can be done. What we see in the use of timber is that specifically, of course, the countries that originally drove this development have made a full transition. Other countries are using it more targeted, like Denmark does. So particular building typologies get partly built in timber. So we also use the hybrid system a lot. So it's not full timber use, but at least partial timber use as part of this whole biogenic strategy. I think we need to develop more variations that can be used. I mean, obviously, bamboo is an example in some countries, or a potential and opportunity to use bamboo, but it's I consider that similar to timber. The tricky thing is that you have countries that have neither, and there it could become a real challenge. And in terms of biogenic materials, ideally you'd also always look for something that is close at hand. And I know that there'll be some countries that probably won't benefit from large-scale use of timber because it's too expensive to import it and it's not readily available locally. And there we really have to develop a different way of thinking. I know in some cases clay has been able to replace some things, but of course the construction typology of clay and timber is vastly different. So you can't do the same thing with that. Like I said, I don't have a solution. There's not a particular answer to that, but I don't know. It's my experience is that. Yeah, sorry, Ola.
No, I just agree with you, but also, I mean, if you look at the Swedish production of timber for the building industry, since many years, since 20, 30, 40 years, about 80% of the timber is exported abroad already. And it still is, especially now when the Swedish crown is very weak. And I think there's countries, without naming any country, but that has large forests that don't have sustainable forestry today, that will have to develop that hopefully over time in the future, and they will be able to support these measures. But it's not going to be enough timber, so to speak, for everybody. But I think it's really important timber is used for a lot of other things right now. A large part of timber being exported from Sweden to Asia is used for casting concrete, for example, and which doesn't really make sense. And so it firsthand needs to be a building, and it needs to be a building where you are resourceful about, sufficient about your resources. Don't use the material too much, and then we can spread it out as much as we can, because there has been some people in this timber architectural business who promote that you use a lot of timber because that becomes a bigger embodied carbon in your building. But as I said before, let's try to look at cities. Let's try to look at communities in larger scale, so we get the critical mass of the timber spread out instead in more buildings, and rather than a few tall buildings, so to speak.
Sure. Maybe we have another question from Inge. Inge, maybe you can ask your question.
Hi, nice to meet you. I'm also a Scandinavian designer, industrial designer from Danmarks Design School, as it was named before. And I'm teaching industrial design here at the University. I think it's very interesting, these topics, but especially this hybrid, because I wonder if you're also looking at things like off-the-grid living, like the Earthship from Michael Reynolds in New Mexico, and if that affects somehow, because you talk about combining timber and clay, for example. What is your take on that?
Well, as I showed you, this little research project about getting within and below planetary boundaries, that employed a lot of that thinking and a lot of inspiration from these pioneering projects of that type, especially when it comes to materiality, but also the possibility of going off grid, because extending the grid is also an investment in carbon. So even though we have actually quite good grids in Scandinavia, which can be used and transformed, they're already there in many cases. Just expanding it indefinitely is also not an option. But the tricky thing is when we on the bigger scale, looking at that level of autonomy, it hasn't really been. I don't think there's actually a viable climate to realize that kind of autonomy in large scale, because cities also expect buildings to become part of their whole organism. cities don't want to be individual earth ships. They actually want to be one big organism. So when we're looking at using clay, for instance, just as we've had a shift in the use of the possibility to use of timber, with moving from just basically sawn timber to CLT, where we can also reuse lower quality or lower grade wood for more complex constructions, and when we can work in a bigger scale and more efficient scale than we could before with timber. In the same way, clay is also having a transition right now from this sort of original adobe material where you pretty much sculpt out of the soil, which is fantastic, by the way, but it's not really applicable in a modern construction context. Then what's happening now is that clay is finding forms, both in terms of blocks and in terms of slabs and in terms of ceilings, and as I showed, also simple replacement for plasterboard and that kind of thing. So clay has a big potential actually to go in and fill a lot of the gaps that are in a modern construction, and doing that in a very inconspicuous way. You wouldn't necessarily notice that you're in a building that has a lot of clay, but it makes a lot of difference for the values and the performance of the building, and it has these good microclimatic functions. So I think we'll see a lot more of that because it's actually the same building process. It doesn't pose a challenge to how we build and the long-lastingness of buildings, but we can incorporate a lot more of that kind of biogenic materials on a low level. So I think this goes sort of hand in hand in the development of technologies. Yeah.
So the future is, would you say, it's a lot about finding these hybrid connections?
Absolutely, and I think again, there's a lot about making that available. So for a long time, modern clay construction was only for enthusiasts who would take on the challenge of figuring out how to build a clay building, and now it's just material that you can order and use instead of other materials. So it's a simple way of upscaling the overall sustainability and the performance of your building.
Would you say, like, when I look at these schools that you have made, it's like it feels like returning to nature, also connecting the urban citizen to the environment it doesn't always have access to?
No, that's true. That's also a big factor, of course. I mean, the whole biodiversity and greening the cities and our microclimate, there's a lot going on there. But I mean, that has to be independent of what kind of material we're working with. That needs to go for every kind of construction.
All right, thank you.
Okay, thank you for your question, Inge, and also answers. Maybe Sinem Hocam.
I can.
Yes, please.
It's the time. First of all, thank you for your presentation. The projects and the research you presented were very impressive. At the beginning of the presentation, you presented a catalog. You shared a catalog with us, which gives SCA data at the very early stages of design. I believe these kind of tools and catalogs are very useful because they communicate better with architects rather than the detailed simulation softwares, I believe. My question is, these catalogs and tools are locally available, or can we access, or because of the data it gives, it somehow contains local information, right?
It does, of course. I mean, the catalog that we made is actually our own data. So we've collated data from various construction projects that we've made and turned that into a catalog just to be able to, as you say, quickly browse it and say, most often we work within the same range of construction typology. So it's easy to have these pre-calculated typology, for instance, for a wall or something, or for a floor slab, and then you can say, okay, if we go with this kind, we end up with this level of embodied carbon, and that can give you a hint in the early design stages of where we're going. The tool that's used to calculate those data is actually a public tool, and that's the reason why Denmark, for example, has been able to make these mandatory caps on CO2. The point is that why doesn't Germany or other countries have the same? Is because they can't agree on the calculational tool. And a lot of the data actually comes from Germany. So it's ironic that in Germany, there are plenty of super well-developed tools, but none of them are the single tool that we use to make comparisons. So our Scandinavian LCA tool is probably not perfect, but since we use the same tool, we can now compare. And that's really the key to taking that step, to actually putting that into building code as well. You need some kind of joint calculational tool which everyone uses. And then based on that, we can then again extract data, and then we can start to work on these catalogs. And so that's really the key step. So this particular tool that we're using here in Denmark is developed by the university in Aalborg, and it's an open source tool that's on the internet. Everyone can use it. It's available in a multitude of languages. So that's already there.
I see. So you have a common tool, which is very important, so you can make comparison.
Exactly.
I think it's the most important thing, because while giving decisions, making comparison is the best method among the options.
Exactly. And also in this case, because it's now a legal requirement, it has to be the same tool, because everybody uses their own tool. It's chaos, they can't.
Yeah, definitely. Thank you.
Okay, thank you very much. Other question is coming from Hatice, I think. Yes.
So, Hocam, first of all, thank you for your presentation. I want to ask, actually, I heard, almost heard my answer. Another student asked it, the places were very hard to find a timber. But I also want to ask about the foundations of timber structures. For example, in my country, the 80% of the territories are covered with desert. It's very weak, and we don't have any tall buildings. First of all, it's not, I think, logical to make from reinforced concrete, because after 100 years it will fall. And second of all, it's we don't have any access to timber at all. It's desert, and we don't have a lot of actual plants. And my country actually made a record in the increasing of temperature on the in our planet, when in other countries it's 1%. In my country, it increased to 2.2 degrees. It's very high.
Yes.
And considering about also sustainability of our cities, we started renewing our cities since collapse of post-Soviet. We were territories of Russia once, and I wanted to ask about timber and its foundation in deserts, how it can be considered.
Hatice, can you say the name of your country, please, for our guest? Okay, you are not. Your hometown is where? Turkmenistan.
Okay.
Yeah.
I have to say I don't have a lot of experience particularly with the desert, and therefore it's a tricky question for me to answer. I think I don't know, Ola, are you familiar with that?
No, we build mainly on the south part of Sweden, and in Denmark it's mainly clay, and if we're lucky we have rock to build on. All the sea bottoms, but desert we haven't worked with at all, I would say. So I'm not going to make any guesses. I would suggest that you talk to somebody who have that experience.
Yes, it's a difficult question, because I think
Okay.
there are certainly peculiarities there. But one thing that's usually interesting is actually to look at the traditional architecture from, say, 100 years or more back, because that's usually based on some kind of simple available solution. And sometimes that can be twisted in a modern way and actually be reused. A lot of that was forgotten in the past decades, but it could be brought back, I think.
Maybe we can talk with Hatice later about the solutions in her own country. I
Yes.
can advise some things later. And we have another question from all the same students asking the same question. So only the 3 or 4 questioners we have. But this is the last one, I think. Aisha, please ask your question shortly.
So we were talking about biogenic materials, clay, timber, but last year I discovered that there is such a thing as expanded cork board and blocks, and you can use it as a structural material as well as the finishing material as well as insulation material. So I don't have a specifically question about that, but this material, do you have any experience on it? Do you have anything to say how it's good, how it's bad, for what it can be used, and what is the future of it?
So
If
the
you
only
work with that.
the only practical experience we have is actually from insulation. So using recycled cardboard and paper for insulation, that is widely used, and it works even in the tricky Scandinavian climates, which tend to be very wet, which is a risk with that kind of material. But even there, it is actually applicable. So that experience is largely positive. Haven't used it as load-bearing materials or something like that before. But I think what's happening here is that actually the Scandinavian countries used to be, or still are in many ways, major exporters of cardboard and paper pulp. But a lot of that production, especially of paper, has now changed to actually be more timber construction based. So a lot of the wood that was originally turned into pulp is now being repurposed for other uses. And that's certainly one of the things, as Ola said, we're looking to the availability of timber. That's an important thing, is actually to make a little less cardboard and paper and pellets, and use the timber in a more sensible, I'd say, more sort of high level. You can always downcycle it later when it comes to the end of life of buildings, etc. That can still happen. But what we do right now is a lot of the timber that's grown is actually downcycled immediately before it's then exported, and that is a shame, because the material is too good to use for that.
Actually, maybe you didn't hear me right. Like, that also was my question, but it was another question.
Oh,
I was
okay.
talking about expanded cork board.
Oh, sorry.
Cork,
I thought you said
blocks.
cardboard. Okay.
No, I was meaning
cork.
cork, like you know, the bark of a
yes.
tree.
Cork
but exactly the expanded cork.
It's a super nice material, but particularly expanded cork, I don't know about. I mean, I've heard of it, but I've never used it, so I can't really say. I was wondering if cork isn't a more short material or more rare material than timber is in general comparison, because it's specifically only a few trees that will grow cork. But again, here I'm guessing, so I don't know exactly.
Okay,
it's
thank
very
you.
interesting, because there's like, it's even it can structurally bear some loads, but in low rise. So I was wondering if somebody actually worked with cork, but
yeah, no,
okay.
sadly not. But I know it as a beautiful surface material, but we've never used it structurally
as well.
Yeah.
Okay, thank you very much, Aisha.
Thank you.
Aisha is focused on cork as an organic material for more than 2 years, I think. Yeah, we have. So she wants to ask this question to you also, to understand if your options or your idea. And okay, thank you very much for the detailed information and detailed presentation. And we already seen timber is a good solution. Timber concrete, timber, steel, and timber hybrid solutions you shared with us. Thank you very much for this presentation. Thank you very much for your time, and thanks a lot. I want to say for all for all students, also for myself. Thank you very much.
Thank you for the invite, and very nice to see you.
Thank you very much.
Thank you very much.
Good luck with your projects.
Yes.
Thank you very much.
Bye bye.
Bye bye.
Great
Thank you very
presentation.
much. Goodbye.
Goodbye.